Alrighty, y'all, welcome back. I'm in my Florida attire today for extra credit. I'm late. I know I'm a day late. I'm sorry. I went home this weekend for my birthday, and my car blew up on the way. So, very unfortunate. I've been having some problems. But, again, it was my birthday. It was the end of the month. But my parents are essentially like, find a car. You have work next week. You have school next week. We don't want to drive you. And it's the end of the month, so they do better deals and whatnot. Here's my car getting towed away right here. So anyways, whatever, let's get into this problem. So to start this problem here, what you have to remember is that the Laplace transform of a derivative to the nth power is s to the n times the Laplace transform of y minus s to the n minus 1 times y of 0 minus s to the n minus 2 times y prime of 0, all the way up until you get to minus y to the n minus 1, and this is going to be s of 0 times that. So to start this problem, I usually like to start out with writing y triple prime is equal to, and then I write out what it's equal to. So that's going to be s cubed times the Laplace transform of y minus s squared times y sub y of 0 minus s times y prime of 0 minus y of 0. And then double prime of 0. And then y double prime is going to equal s squared times Laplace transform of y minus s times y of 0 minus y prime of 0. And then y prime is going to be s Laplace transform y minus y of 0. Now we're going to rewrite it using these here according to this here. And we're going to do this by doing, actually, you know what? I'm just going to copy paste, make it easier. So we're essentially going to have all of this here. And it's going to be minus everything here. Everything here. And then it's going to be plus everything here. And messing this up. And then it's going to be minus y equals 0. So as we have up here, we know that y of 0 and y prime of 0 is equal to 1, and y double prime of 0 is equal to 3. We can go ahead and plug everything in and rearrange, and then we're going to get the Laplace transform of y times s cubed minus s squared plus s minus 1, and then it's going to be plus y of 0 times negative s squared plus s minus 1, and this is going to be plus y prime of 0 times negative s plus 1 plus y double prime of 0 times one here. And when you plug everything in, you will eventually get Laplace transform of y minus s squared minus 3, and this is all times s cubed minus s squared plus s minus 1 is equal to 0. So you're going to solve for Laplace transform of y, and that's going to equal s squared plus 3 over s cubed minus s squared plus s minus 1. Then what you're going to want to do is go ahead and factor that, and this is going to equal s squared plus 3 over s minus 1 times s squared plus 1. Now next we have to do partial fraction decomposition, and to do that we're going to have a over s minus 1 plus bs plus c over s squared plus 1, and that's going to equal this function up here, or not function, but you know what I mean. We go ahead and multiply this out. We're going to get a times s squared plus 1 plus bs plus c times s minus 1, and that's going to equal s squared plus 3. You go ahead and you can set it up like this: s squared times a plus b plus s times c minus b plus a minus c equals s squared plus 3. Set the coefficients equal to each other, so you're going to have a plus b equals 1. You're going to have c minus b equals 0. And you're going to have a minus c equals 3. So you go ahead and now we're going to solve this system of equations. And then we're going to get a equals 3 plus c, b equals 1 minus a. Then we're going to go ahead and plug in. We're going to get b equals 1 minus 3 minus c. And then we plug this in. C minus 1 plus 3 plus c equals 0. And from that, we'll find 2c plus 2 equals 0. So c equals negative 1. Go ahead and plug in for the other ones. We'll get a equals 2 and b equals negative 1. Now we're going to go back to our original one here. We're going to rewrite this. So what we said, a is 2, b is negative 1, c is negative 1. So we're going to solve this, and we're going to get 2 over s minus 1 plus, and then b is negative 1, c is negative 1. So this is going to be minus s plus 1 over s squared plus 1. So I'm going to take all this here. I'm going to bring it down. Bring it down here. Now we've essentially solved this, and this is equal to the Laplace transform of y, like we have all the way up here. So coming back down here, now we're going to take the inverse Laplace. So we're going to take the inverse Laplace. This is going to be of the Laplace transform of y. Inverse Laplace here. I can't do the curly brackets, so s squared plus 1 here. So this is just going to give us y is equal to the Laplace transform of this, because this is in the form of 1 over s minus 1. So this is going to be 2 times e to the t here. So we're going to get 2e to the t. And then this part here, we're going to break this up. I'm going to draw this over here to s over s squared plus 1 plus 1 over s squared plus 1. And then remember, this is a minus times everything because of this minus over here. Now, if we look at our Laplace transforms, this is going to be equal to cosine t. This is going to be equal to sine t. You have this here times the negative. Our final answer is going to be 2e to the t minus cosine t minus sine t here. And that's how you solve it. So, all right. I hope you enjoyed this video. No outro music for you today, but yep. Okay, that's all. Goodbye.